Welcome to Math 098. We're at 2.5 and we're just practicing graphing some more. Starting with some of the straightforward problems where, y equals mx plus b, where you start with your y-intercept. So as we look at this problem, my y-intercept is 2, up 2, and then my slope is rise over run, so we're going to rise 3, and then run 4. So in this problem, again, I need to see the tick marks 1, 2, 3 over 1, 2, 3, 4 right here. Now I do want to point out that I've seen some students, I would not suggest you do this, but if you've been doing this in the past, it's fine, that they start at 2, then they say, oh, I'm going to go up 3/4 and then right 1, up 3/4, right 1, up 3/4, right 1, up 3/4, right 1. You'll notice that you end up in the same spot as if you went up 3, right 4. So it is acceptable, it's just not advised, if that makes sense. So there's two ways to do the next one. Probably the most familiar way is people subtract x to the right side and then divide everything by 2. So you got y equals -1/2 x plus 3 and then graph from there. I also want to point out the method that we talked about in an earlier where you can find the intercepts by covering up one of them. So we have an x-intercept at 6 and then go back, and then cover up the other term. So you'd have 2y equals 6 and divide by 2, so your y-intercept is at 3. So then going back, you can say, oh, okay, well, my x-intercept's at 6. My y-intercept is at 3. There's my 2 points. I can connect those dots. Try your best to make a straight line. Clearly, I'm not very good at drawing a straight line. But if you notice, it is the same as this method where I went up to 3, then down 1, right 2, down 1, right 2, down 1, right 2, and they land on top of each other. By the way, we're graphing linear functions right now, so we're good. This next one, they're asking you to write the equation now. Now, there's two ways to do this. Probably the most common way that you've been taught before is to start with this premise of y equals mx plus b. And then in this problem, you have an x value, 0, for the y value, 4, and this represents m. So you can start plugging in. Okay, so we have 4 is y, -3/4 is your slope, your x value is 0. Well, what's my y-intercept? Well, now you can solve it because anything times 0 is 0. So you want to multiply first and then subtract whatever that number is. In this case, it's 0 over, well, 4 minus 0 is just telling me that my y-intercept is 4. So now when we write the equation, we want to put y and x back into it and then put your slope, the -3/4, where that belongs, plus your y-intercept, which we found earlier, to be 4, where that belongs. There you go. And so I'm going to do the same thing for the next one. Find an equation of the slope line with the slope of -4, containing the point -2,5. If there's ever confusion on what I mean by this, if you see a negative sign, it's because I want it to be -4. So same equation that we had up here. I'm going to replace m with -4. We have the x-coordinate of -2. I don't know the y-coordinate, the y-intercept, but I do know that the y-coordinate is 5. Just doing this. So if I do the problem the same way I did before, -4 times -2 is 8. Well, now I can subtract 8 over here. So my y-intercept is now -3. So like I said before, the equation, go back and put y and x back into it. -4 is my slope, and the y-intercept I found out was -3. All right. Now that's not the only type of problem that you'll have. You'll also be asked to find the equation in slope-intercept form, except it's now asking you for function notation. But if you ever see function notation that is slope-intercept form, and instead of y equals, you're going to write f of x equals, something x plus something. But here's another issue, is they don't even tell you the slope. So you have to find the slope, and that's the formula we talked about in an earlier lesson, y2 minus y1 over x2 minus x1. So if I'm doing this, I would use y2 to be this value. y1 is this value. You don't have to do it my way, but my way does work. So that means x2 is that value, and then x1 is this value. So I'm looking at negative 2 over 3. Now, when I go back to slope-intercept form, I'm going to scroll down again. Now I know that the slope is negative 2/3. But my x and y value, I get to choose. Do I want to use this one or do I want to use this one? It doesn't matter. Now I circled this one a lot because I like dealing with 0, because anything times 0 is a pretty easy number to deal with. All I have to do now is figure out that negative 2 times 2 is negative 4/3, because remember the denominator stays the same when you multiply fractions. And it's easier for me to add 4/3 to 0 than some other number. So my y-intercept is now 4/3. And then don't forget that your slope goes right here. So negative 2/3 x plus 4/3. That's how we want to write that problem. At any point, if I'm going too fast, don't forget you can pause, rewatch a video, go back, do other things. This problem's a lot different because now they're asking for the answer in standard form. Now remember, standard form is that ax plus by equals c. Well, that looks like a G. Sometimes my handwriting gets sloppy. And remember, a, b, and c must be integers. And you should be familiar with this notation from Unit 1. Now, the easy way to do this is to do slope-intercept form. Okay, because it's clear that it crosses the y-axis at 5. Now, what may be less clear to you is what's the slope? Well, I can just count down 2, right 3. And that's telling my slope. Down and to the right, so negative 2, right 3. Now, the issue that we have is these are not integers. Well, 5 is, but negative 2/3 is not. So maybe I should do this in a different order. What I'm going to do is add 2/3 x to this side plus 1y, because remember that's 1y, is equal to 5. And I hope you're okay that I just added 2/3 to the left side. But we have to make them integers, and we can do that by multiplying by the common denominator on both sides. It only works if you multiply by both sides. So as I distribute this in, well, 3 times 2 is 6, divided by 3 is 2x, 3 times 1 is 3y, and 5 times 3 is 15. This is how they wanted you to write this answer. Exercise 7, you might want to pause the video and read it and understand the problem. What I would do is look at the time. And what I would do is I would make x equals 0 represent one of those two things. So it makes more sense to me to set 2008 to be x equals 0. So then how much time must pass before we get to 2012? And you can even count with your fingers. Like 09 would be 11, 10, 11, 12. I counted 4 years. So then you can use basically your slope formula, y2 minus y1 over x2 minus x1. And by setting one of them equal to 0, it makes your math so much easier. And let's see, I started with 2012, so I need to start with 9198 minus 7513. And And you already know I'm about to go to Desmos. And what's nice about this is you can just type it in exactly the way it looks, or knowing that 4 minus 0 is 4. So we get a slope of 421.25. 421.25. And so what I can do is I can write an equation, 421.25. Now, let me do this really quick for you. If the y-intercept is always the y value when x equals 0, and I let x equals 0 be 2008, then it makes sense that your y-intercept will just be that 7513. So now when I go back to Desmos, I can just type into my equation 421.25 plus, sorry, I'm going to put x for a second, plus 7513. Now the thing is, we don't know what x is, but it's asking in 2020. Well, how many years need to elapse from 2008 to get to 2020? We're going to change x to be 12 years need to elapse. They need to happen. So I can go back to Desmos and just change that x to be 12. And I'm going to predict 12,568. That's my answer. There you go. Again, feel free to go back and rewatch anything as you do this. This next one, if you understand everything, it makes perfect sense. What kind of equations have horizontal lines? Y equals, always. What's the y value here? -2. That's all you have to do. Really, really easy. What about undefined slopes? Well, an undefined slope is x equals. Well, what's the x value in this problem? 6. It saves you a lot more time than actually plotting this point. 1, 2, 3, 4, 5, 6, -2. And think about, well, if it's a horizontal line, I got to draw it like this. And if it's a vertical line, I got to draw it like this. It makes perfect sense if you really work it out. We have 2 more problems. I think I can get this done before my time runs out. What's important about this is we have a parallel line. Well, let's find the slope of this first. And that's by subtracting 3x over plus 1. And when I divide everything by 4, I get -3/4 x plus 1/4. But all I care about is this slope. So going back to this problem, my y value is -3. My slope is the same. My x value is 8. But what I don't know is what the y-intercept is. So I can figure that out by doing this math. 8 times -3 is -24. Divided by 4 is -6. And then add 6 over, and you get a b value of 3. So this equation, I'm going to leave it in slope-intercept form because I'm running low on time. I'll leave it to you to change it to standard form. It's good practice. -3/4 x plus 3. What you would do is multiply everything by 4 and then add 3x to the left side. Or there's another way of doing it. If you notice that this problem is the exact same, except they change parallel to perpendicular. So if this slope was -3/4, notice that everything's the same. The slope of the perpendicular line will be the opposite, so positive 4/3. So if we were looking at that, you would do everything the same way, except change the slope to be 4/3 times 8 plus b. Well, 8 times 4 is 32/3. I'm going to default to Desmos again. And so 32/3, and then you have to subtract it to the other side, so you get -13.6 repeating for your b value. So your equation on this one is 4/3 x minus 13.6 repeating, and you're ready for the homework here. and my time ran